2.4 exact equation. Let's take a look at the definition. A differential expression, a differential expression m xy dx plus n xy dy is an exact differential in a region R of the xy plane. Okay, if it corresponds to the differential of the function fxy, a first order differential equation of the form differential equation of the form m xy dx plus n xy dy equals 0. Okay, is said to be an exact equation if the expression on the left hand side is an exact differential. Differential. Okay. So here gives us the definition of exact equation. What is the exact equation? That means this equation has an exact differential on the left side, this side, okay, left side. So what is exact differential? Now let's take a look at the criteria, okay. Theorem 2.4.1 criterion for an exact differential. Okay, let m xy and n xy be continuous and have continuous first first partial derivatives in a rectangular region are defined like that, defined by a less than x less than b, c less than y less than d. Then a necessary and sufficient condition that mxy dx plus nxy dy be an exact differential is what is here. It's partial m divided by partial y, partial n divided by partial x. Okay, partial x. And the condition is this guy. Okay, so as we can tell, how to judge whether this guy is exact equation. That means we need to check whether partial m is the function in front of dx, and partial n is the function in front of dy. Okay, we just needed to make sure we satisfy this condition. Then we can tell that is exact equation. Okay, exact equation. Or you can write down it this way. If it's exact equation, we can write down as like that, partial over partial x dx and the partial y over partial y dy. Okay, and of course you can tell this partial f over partial x equals mxy. This partial y f over partial y equals n. Here. Okay, so we can tell partial f over partial x equals mxy, partial f over partial y equals nx well. And this f, if we can find this f has partial f over partial x equals mxy, partial f over partial y equals nxy, then we can find the solution. Fxy c is the solution of of this guy. Okay, so there are several things needed to address before we solve this exact equation. Okay, so the first step, you need to check whether this guy is exact solution or exact equation. How to check whether this guy is exact equation? Just check this condition. Okay, I label on this condition. Partial m over partial y equals partial n over partial x. What is m? M is a function in front of dx, and n is the function in front of dy. So, okay. And after you know that is exact equation, then you can use this formula. Use this formula to find this function, this function. And as we can know, that is the derivative. How to find the fx and the derivative? We do the integral. Okay, we do the integral for this guy. We do the integral for this guy. Okay, now let's take a look at an example. And so this example going to help you guys to understand it. Okay, so the first example is here. So for example, I give you 2xy dx. Okay, and in order to check whether this guy is exact equation or not, we need to write down the m. M is the function in front of dx, so that is 2xy, and nxy is the function in front of dy. Okay, we have these two. Very good. Now, so we need to check the exact equation. Now that means we need to check the partial m over partial y and partial n over partial x. We're gonna check these two, whether these two equal each other, right? If equal each other, that means they are exact equation. Then you can use a following condition, okay? If it's not, you couldn't use the following condition. So that's the key part. Let's do the partial derivative, okay? So partial m over partial y, that's the derivative with respect to the y. All right, so we keep the y as a variable, keep the other variable as constant, right? 2x as a constant. So do the derivative with respect to y, going to be 2x. The same things. Partial n over partial x. We do the derivative with respect to a variable x. All right, and we'll keep the other terms as a constant, that is 2x. Okay, so good. We can see these two each equals each other. That is exact equation. We get the first condition is satisfied. Exact equation. Now we can use the property. We use these two conditions, the first condition and the second condition. And we know partial f over partial x equals mxy, right? That's the first condition. That equals what? That equals 2xy. Okay. Now, how to find the derivative of the function of f? Here's the derivative. How to find the antiderivative of f? Just do the integral. So fxy will be, here's partial over partial x. So do the integral with respect to the x. Okay. So if I give you such things, how you calculate the f? just do the integral, right? And the derivative gonna be integral. Integral this guy with respect to the x. So if you do the integral with respect to x, consider all the other terms as constant. You can put 2y outside, right? All the other terms are gonna be constant. You can move outside, and we're gonna have, right? And the derivative of x gonna be x squared over 2. That's the first one. Now we're gonna check the second one, partial f over partial y. That is x squared minus 1, right? The second condition. The same things. Same things. In order to find the fx, we need, what are we gonna do? We need to do the integral. And be careful, these are partial derivative with respect to the y. So we need to do the integral with respect to the y. Right? With respect to. As you can tell, the only variable is y. Here is x is a constant, right? X squared minus 1. So put outside, dy should be y plus c2. Okay, plus c2. So that's the antiderivative from this condition, and we can write down here. Okay, so what is fxy? Now we're gonna do the combination, and this is the key part. Okay, key part. We're gonna do the combination to find the function fxy. So here we have a common term. Okay, we both have x squared y and x squared y. So we just pick one term. Okay, if there's a common or repetition, xy squared y. Here is also x squared y. We just pick one. Okay, pick one. And we found that here we have extra term, negative y. Here it doesn't have negative y, just pick a negative y. Okay. And you also can pick a C1. We find the function that is x squared minus y times y minus y plus C1. Okay. So, or plus C3, for example. Now we let this guy, for example, equal to constant. And of course, you can write down as equals C. Okay, equals C. And it's the solution of ODE. Okay. So the key part is how you pick the fxy. Okay, fxy. So if there's a repetition, x squared y, you just pick one. If there's extra terms, you just pick one, negative y. Okay, pick one. Pick a negative y. Okay, and also you can write down the constant. Usually people don't like to write down the constant on the on your homework. Okay, so on your homework, probably just like that. The format will be x squared y minus y. Okay, and then you can say this guy equals constant is the solution of ODE. Okay, let this guy equals constant is the solution of ODE. Okay, like we mentioned before, like that. After you do the integral and let the fxy equals the c is the solution. Okay, so I probably would like to follow this way. Don't put a constant there, just write down the fxy, pick the x squared y and negative y. Okay, if that's constant, we're going to pick it. And let this guy equal c is the solution of ODE. Okay, now I'm going to give you guys an example. Let you guys try it. Let me check. That's so complicated. Too complicated. Exact solution. Okay, here. So I gave you a problem like that. Example 2. First equation is 4xy squared minus 4y dx plus 4x squared y minus 4x dy equals 0. Okay, and try it by yourself. So first step, you're going to check whether this equation is exact equation or not. And then you can use the two conditions. Find the fxy. Okay, pick the fxy. After you find the fxy, you just equal c. That is the solution of ODE. I give you guys five minutes. Okay, try it. Follow the steps. Okay, follow the steps. You need to tell what is mn, and then check the condition partial m over partial y and partial n over partial x. If equals each other, that means is exact equation. Okay. You're done? You done? Okay, I'm gonna do it. Don't worry. So let's take a look. So the first things you guys needed to figure out what is mxy. Mxy is always the function in front of dx. Okay. Sometimes people would like to write down as this term first today, and then put the dx term following this dy. Okay, so you needed to tell mxy always the function in front of dx. Okay, if somebody switch these two, you should be able to tell what is mxy or what is nxy. Okay, be careful. So here we have now nxy. All right. Now we're gonna check the condition whether this equation is exact equation or not. So we're gonna check the condition. Partial m over partial y. All right. So condition. Just follow the steps. Check this condition. Partial m over partial y. Do the derivative for the y. We treat the x as a constant, right? It's a partial derivative. Did you learn the partial derivative before? No? It's Cal2. I think it's Cal2. Yeah, it's a Cal 2. Did you take the Cal 2?
Yeah, I took Cal 2, but I don't remember none of that.
Okay, so when you do the partial derivative, that means you do the derivative for the y. You don't do the derivative for the x. So if you do the derivative y, you treat the x like a constant. Okay. The idea is very simple. Just treat the x as a constant, like a, b, c, d. Okay. So we'll only do the derivative for the y square. If you do the derivative for the y square, it should be 2y. And do the derivative for the y is 4, right? You do the derivative of y is 4. Do you understand the y? Do the derivative of y square is 2y, right? Power rule. So this guy will give you 8xy. Now partial n over partial x. Now we do the derivative with respect to the x. So we treat the y as constant. Here, 4y is a constant. You just write down the constant and do the derivative for the x squared, going to be 2x. And do the derivative for the x, going to be 4. And we're going to get 8xy minus 4. And you can tell these two equals each other. Right? Then that is exact equation. Since it's is an exact equation, then we can use the condition partial f. And the first condition is partial f over partial x. Right? This condition partial f over partial x equals mxy. Mxy is here. It's 4. Okay, mxy. Okay, now how to find this f? Use the integral of this guy with respect to the x, right? And you need to be careful. Here we do the integral with respect to the x. That means we treat the x as a variable, treat the y as a constant. Okay, so the first term gonna be 4y squared. 4y squared is a constant, and the term is x squared divided by 2. Right? The end derivative of the x gonna be x squared divided by 2, and minus the constant negative 4y. Right? Negative 4y, and integral of this constant gonna be x, right? Gonna be x. Of course, you can write down as c1. You can simplify this guy. Okay. Did you take the Cal 3?
No, Cal 3.
You didn't take a Cal 3. I think Cal 2 should teach you guys the partial differential equation. Oh, I mean, the partial derivative. Okay, anyway. Now we have second condition. Second condition is partial f over partial y equals nxy. So partial f over partial y equals nxy is here. Okay, and then we do the integral of the whole things. Okay, integral with respect to the y, because here's a derivative with respect to the y. If you wanted to find the antiderivative, just do the integral with respect to the y. Okay, so we treat the y as a variable, all the other terms as a constant. So we have 4x is y. For the first term, we have antiderivative is y squared over 2. And this is a constant. So negative 4xy, for example, C2. We can simplify it. 2xy, 4xy plus C2. Okay, very good. Now you can pick fxy. Here we have repetition, 2x squared y2. So we just pick one. Okay, we have 2. Just pick one. And here we have another repetition. That is negative 4xy. Here we have another 4xy. Just pick one. If there's a repetition, just pick one. Okay. We got this one. And we can say that guy equals C is the solution of ODE. That's it. That's it. Now I'm gonna give you guys another one. Okay, let you guys try the game. Make sure you guys understand the steps. Okay, understand the steps. So let's do another problem. Let's try this one. Okay. Try this one for me. Follow the steps, okay? Especially when you do the derivative, partial derivative, you just consider the variable, one variable, and then consider the other variable is constant. The same thing for the integral. You do the derivative for the variable, specifically x, for example. Then you consider the other variable as constant. Okay, try it. I give you guys about 5 minutes, and I wish everybody gonna make it this time. Okay, follow the steps, step by step. I think you can do it. Did you get it?
I didn't get the, I get, partial M over partial Y.
Okay.
They're not equal. I didn't get the.
You didn't get an equal? You probably make a mistake. Partial m over partial y. If you do the derivative with one variable, then you treat the other variable as a constant. Derivative of that constant equals 0. Right? Okay. I'm gonna write down the the steps. So here we have what? Right? We have this guy and partial m over partial y. That means we do the derivative for the y, and this term should be 0, right? Because this is constant. Derivative of constant is 0, so we should get 4. And partial n over partial x, that equals what? This term is 0, this term should be 4, right? Equals each other. Which step will you make a mistake?
I didn't put a 3x to third 0. I just took outside and let the whole thing is constant.
You mean these terms?
Yeah.
Okay. Just when you do the derivative, this is some rule, right? You do the derivative for each term. So the derivative of this term constant is 0, 0 plus this term is 4, right? So basically it's 0 plus 4 equals 4. And when you do the derivative for this guy, will be 4 plus 0, right? Derivative of a constant is 0. So what you can get from here is 4, from here is 4. Okay. Now let's continue. Since we know that's the exact equation, we're gonna have partial f over partial x equal to mxy, right? Mxy. Follow the condition. And how to calculate? Do the integral. Right? Do the integral. So for the first term, we do the integral. We're gonna have x4 divided by 4. Second term is a constant, just times x. Okay. Second term is a constant, and this guy will boils down to the and the second condition. The second condition gonna be what? It be 4x um, for x plus y, right? For x plus y. And what are we gonna solve it? We do the integral. We have this guy, dy, dy. And then we do the integral again. Since we do the integral with respect to the variable y, we treat the x as constant. Right? So we have what? 4xy plus y squared over 2. Okay, the first term is 4xy plus y squared over 2. Now you can combine the terms. We don't have these terms here. We pick this term. And we have repetition 4xy. We just pick one. And we have this term. Right? We find the fxy, and let this guy equals what? Equals c. It's the solution of ODE. The solution of ODE.